And we're back, aren't we? So what we're doing, a little bit of trigonometry. And last time we were drawing the graphs. Now we're going to get given the graphs and we're going to have to find the equations. So quickly here. A, what is the effect of A? Well, A kind of changes it, makes it stretch. Of course, it could reflect the graph as well. So if it's a negative, it could reflect it about the x-axis. What's the value of this P over here? Well, that P is going to move it left and right. And finally, we've asked this one, the last one, but what's the value of Q? Well, Q moves the graph up and down. Now we've got sine x. So for reference, we're definitely going to need a graph of y equals sine x. So I'm just going to draw it something like that from 0 up to 360. So we know that's 180. It's just kind of our base point that we know that's what that graph looks like. Okay, so now we need to change that yellow graph into the one in the picture by changing A, P, and Q. Now, A kind of tells us how much it's stretched by. So if this one went between -1 and 1, and this one's going between -1 and 5, what's the amplitude of this new graph? Well, the amplitude is not going to be 6, remember, it's going to be 3 because amplitude is kind of 1, 2, 3. Like these are kind of the center point of our graph, and it's going up by 3 and down by 3. So our amplitude is 3. So now what we could say is, we could make A 3. So let's draw what we've got so far. So over here, let's move out the way and say that if we drew y equals 3 sine x, it's going to look something like that, right? So that would be up at 3, that would be -3, and we can still going to move it up and down and left and right. But this blue graph over here, over there, looks kind of almost too different to this graph over here. Of course, we could move it quite a lot. But what I would suggest is, instead of doing that, why don't we say, let's make the value of A -3. And then that red graph is starting to look a little bit more like this graph already. So I would go with saying that A equals -3. So let's stretch it by 3 and reflect it. Okay, so we've got that. So we've got that red graph so far, so I'm going to get rid of that blue one there. Okay, now the next thing is we've got this moving it left and right, or let's move it up and down. Moving up and down seems like it's not going to be too much of how much we've moved it up and down. Well, if the lowest point was -3 and 3 on this one here, how much do we have to move it up or down by to get this graph over here? Well, clearly we've moved it up by 2, right? Because it's -1 to 5, not -3 to 3. And so therefore we've got our value of Q, and Q must be +2 because we've moved it up by 2. So far what we've got is y equals -3 sine x minus p plus 2. We reflected it and we moved it up. So this graph now, if I drew it over here, has gone like this. That's kind of the graph, and it carries on a bit. And this point over here, we've got this point, we've got kind of a highest point. The highest point is at 5. The lowest point's at -1. We don't know what this x-intercept is here, or the y-intercept. Oh, wait a second. The stretching and reflecting didn't change the y-intercept. But now this y-intercept's moved up, so it's kind of midway between those. So that's going to be a 2 at the moment. So clearly it's kind of moved to us, so the graph needs to move a little bit left. Okay, so take a pause, take a breather, see if you can kind of see what's happening. We've got the purple graph, and we need to turn it into this graph over here. It's almost there. We just need to move it left by a smidgen. Okay, so let's see how much we need to move it left by. Now, the only key bit of information we're told is that its y-intercept is 0.5. We don't know what that number is there. We don't know what these intercepts are. If we were told them, well, it would probably make life a whole lot easier. So let's see what we got so far. If I drew this purple graph onto this one here, it's got this value at 90 degrees, right? And this was at 2. This value here was at 270, was up here, and at 180, where am I? Okay, so let's just focus on these bits here, because I don't want to look at all of them. It's just this bit on the left here. So that's what our graph looks like from moving it up. Now we need to move it left. So our question is, how much do we have to move this graph left by? What value would have made that a half? That would maybe help us answer that. The question is, how much do we have to move this graph left by? So we got this value at a half, and if we knew what value would have given a half, it would help us what that point is. In other words, what we know is that for the purple graph as it stands, so the purple graph as it stands looks like that. Minus 3 sine x plus 2. And we're trying to turn it into, let's call this one the green graph. Let's make it like this so we can keep track of it. So our green graph over here, there it is there. We're trying to turn our purple graph into our green graph. And we're going to see how we're going to do that. How much do we have to move it left by? Do you have an idea already of how much we have to move it left by? Okay, maybe you've got an idea, in which case you're like, okay, well, let's watch the rambles and see if the rambles get there. Or maybe you just write, I have no idea, like, where are we? But you should have the idea that it's reflected, stretched by 3, and moved up by 2. Okay, so what we want to see is this value here. Let's just sub it in and see if it makes sense. We've got a half equals minus 3 sine x minus p plus 2. That's just by subbing in this point that's hidden away over here, 0, a half, into our equation, which is just another way of asking the same question I've asked, but maybe having it written down helps. So we're seeing how much do we have to move it left by so that this is true. So let's subtract 2 from each side. So we got minus 3 over 2 equals minus 3 sine x minus p. And divide both sides by negative 3. So we've got a half equals sine of x minus p. But wait a second, what was the value of x at this point? Well, x is 0. So we can replace x by 0 and go, okay, so sine of negative p equals a half. Well, sine of what gives us a half? To the rescue. And either we're going to do special triangles, or we're going to go, well, it's either going to be 30 or 60, right? 30, that seems right. So sine of 30 equals a half. So negative p must be 30. In other words, p is negative 30. We've moved the graph left by 30. So remember, what our graph looks like is y equals minus 3 sine x minus p plus 2. Remember, we're moving it left by 30, which means this must be plus 30. Okay, something to take in, right? Something to take in. Cool. Let's head into this bit here, because this is surprisingly easier, because we don't have 3 variables to work with. And the key questions that I'm going to ask you are, how do you do each of these as opposed to going through and doing each of these? So we need to find the value of a and b. Now, a little bit easier this time. So let's highlight our graphs. And if you don't have this in front of you, it gives you a chance to jot it down as well. So here's f of x over here. Look at f go. That's sine ax. And the other one we've got going along here is this bit over here, and that's cos x plus b. Now, I'm not going to ask you again for the umpteenth time what the effect of A is. We know that A just stretches the graph, so, and possibly reflects it. So if A sine X, well, it looks like all we've done, no, A doesn't reflect it. We haven't done this A yet, hey. Let's ask the question. What is the effect of that A? So we've got y equals sine AX. What is the effect of that A? Well, what that does is it changes the period, like we did for the tan graph. Everything happens quicker or slower. So this graph looks like it's a sine graph, and normally sine repeats itself every 360. This repeats every 180. So everything's happening twice as quickly. So y equals sine 2x. Okay, and for our other one, maybe let's just ask it. What's the effect of B? Well, B moves the graph left and right. So this graph of cos x, remember, normally starts here at 0, 1. And this graph is at 45 and 1, so it's moved right by 45 degrees. So therefore it's y equals cos x. What should be the other term in this bracket? Remember, it's moved right by 45, so x minus 45, because it's moved right by 45. Oh, damn calculator. So it's moved right by 45. Okay, so that's A and B. So the last 3 questions, 1, 2, 3, 4 questions, because 2 of them are the same, are as follows. How are you going to find out what the value of B is? Okay, so to find out B, for me, I think, well, that's the lowest part. So let's just take our kind of cos graph here and see, well, where would our lowest part have been? And everything's moved right or right by 45 degrees. So that'll help us find out what B is. Same question applies to maybe C and F. This point over here and this point over here. How are you going to find out what points C and F are? Well, it's where the graphs are equal to each other. So you can put the graphs equal to each other. Just a word of warning, when you do that, it's not quite an equation we know how to solve yet, and we're going into solving equations soon enough. So for that, just try some values and see which ones make sense. So try, it's not -60, but try -60 and see if that kind of works, and see if you get the same answer. So try a few. We don't have a good method to do that just yet. Okay, how are you going to find out what the value or the coordinates of point D are? Okay, well, for me, I know that x is 0, so I can just sub 0 into the cos graph. Okay, and the last question then is, how are you going to find out what the coordinates of point E are? Well, for E, again, we know something about E, that's 0. So you can either sub in 0, so 0 equals, and it's on our cos graph as well, so cos x minus 45, and try and solve. But you also know that the graph has just moved right by 45, so see where that point was and move it right by 45. That's easier than trying to solve some sort of equation here, which is kind of what you do anyway. Okay, so there you got some ideas of how to do it. I'm not going to go through this next example here on this video. I think you've had more than enough video time today. So I'm going to finish off in a next video. I'm going to do the rest of this question. I'm also going to do this next question entirely optional. You can come into this PDF to go and check. As I said, the video will be on the website and the answers will be in this PDF, so you can go and look at those, but you don't have to watch that video there. That's it. Enjoy making it maths.